So, during complement what will happen? First, before this, you just try to understand what the complement does. Complement is nothing but accumulator will be having the value in a inverted manner. For complement, this is the job. Then what will happen? Only one value that is already stored in the accumulator, the particular operand. So, here it will be stored back to accumulator again. So, accumulator equals to accumulator bar. So, the result will be stored in accumulator. So, accumulator here, and here the ALU will get the control signal for complement, and it have to complement the value which is stored in the accumulator itself, and again we have to initiate the T0. We have to initiate the T0. So, this is the micro operation for accumulator complement. Now, AND R1. For AND R1, it is accumulator equals to accumulator and R1. Again, you can understand that R1 is not connected with the ALU. So, we have to again copy the value of R1 to the temporary register, that is the data register or the DR. So, in T3 the DR must have the value of R1, and here in the T4 the accumulator will be having the output and ALU will be having the control signal for AND to perform the AND operation over two operand, and then the initial state is initiated, that is the T0. So, again it will move from here and it will start performing the next instruction, fine. Then comes the move operation. Let us see what will happen in case of move. It is move R1 comma R2. Move R1 comma R2 is a very simple operation. You can understand it is a very simple operation. For this particular operation, what you have to do, during machine state T3, we have to copy the value of R2 to R1 and we have to initiate the machine state T0, fine. Likewise, if we want to perform move R2 comma R1, then these three things will be common, and during T3 we have to perform R2 R1 like this. For move R1 comma accumulator, for move R1 comma accumulator, what we have to do, during T3 we will write R1 accumulator and then T0, right, isn't it so, right, clear? No confusion should be here, I think. Likewise, for the next it will be accumulator R1, all right. I think till now you can understand that all these control signals are now discussed, fine. But till now they were the register difference instructions. Now, let us see what will happen if we want to perform any memory reference instruction. What will happen if we want to perform any memory reference instruction? But before starting, we must understand one thing. It does not matter that it is a register reference instruction or it is a memory reference instruction. The first three machine steps, they will be same as it is, it will not change, because they are not instruction specific. You have to fetch the instruction from the memory, you have to decode it by any means. So, does not mean it is a register reference or it is memory reference, it does not matter, fine. Let us take this, that is move accumulator comma memory. That means any particular memory element will be moved into the CPU, that is a memory read operation in particular. Memory read operation, that is move accumulator comma memory. So during T3, the element will be copied to accumulator from memory. Memory is what? Memory is nothing but a foreign body for the CPU, which is connected with CPU by means of bus. I have discussed the bus structure in the very first lecture. There are three types of bus: data bus, control bus, and address bus. So that particular bus, external data bus, will be opened if and only if MAR is having any address in it, which is true here. What I said? I said that we have to ensure that MAR must get the address from where we want to read, which is already taken care of. So we have to perform only one single operation, that is accumulator is equals to memory content of the address held by the MAR. Accumulator will have the particular address of what is the particular value stored in the particular address which is held by the MAR. Let us take an example. Suppose we want, this is the accumulator and this is the memory. This is 100, this is 101, this is 102, 103, 104, 5, 6, 7, 8, 9, 10, 11, like this. Suppose that we want to get the particular element which is stored in the memory 102. Let us make it 5 is being stored in memory location 102. We want that 5 here in the accumulator. What we have to do? First, when the opcode we have to follow, when we will follow it, it is a memory read operation, and we said that the opcode for memory read is 001, and in this 12 bit in the operational field, what we will get? We will get the binary value of 102, the binary value of 102. Fine, fine. Then what will happen? In this particular line, you can understand that 0 to 11 we are having MAR, we are copying this 102 into the MAR. This 3 bit is fed to a decoder. This decoder will say the timing and control unit that we want to perform move accumulator comma memory. How? Because I said that in this case I0 will be high, in this case I1 will be high, in this case I2 will be high, I3 will be high, I4 will be high, I5 will be high, I6 will be high, I7 will be high, I8 will be high. But in case of memory reference instruction, here the result of the decoder will be fed into the timing and control unit. We will discuss this thing after this only. So once this decoder will be saying that you have to perform move accumulator comma memory, we know that it is a memory operation. So MAR must have the value from where we want to read. Now MAR is having 102 and it will copy the memory content of 102, that is memory content of 102, which is equals to 5. So 5 is being stored in the accumulator. This is how the whole thing works, and how timing and control unit will understand, we will just discuss after this discussion. Once this is over, we will discuss that in details. No problem. Don't be scared. Now understand this thing. So right, this is done. If it is memory write operation, that is, if it is move memory comma accumulator, then what you have to do? Achha, okay, fine. Here we have to initiate T0 again, as it is, no change. If it is like this, ki we have to copy the content of accumulator to this is memory read and this is memory write, fine. So these are the operations, these are the micro operations basically, these are the micro operations basically, fine. I think till now it is clear. Now let us proceed further, let us discuss this thing in details.